Am I good? So you had it correct, RJ. This is a project I did on a Wi-Fi controlled switch. Um, Actually, you can delete the word RF and control anything you want. My application was RF. And like I say, I'm not as fancy as PowerPoint. So this was my configuration some years ago. I've got a 43-foot vertical out in the prairie with a remote tuner at the base and about 200 feet of coax between the uh, antenna and the house. So I decided I really needed to have an IC 7300, and I put that in the workshop in the barn, which created a problem. I wanted to use one antenna on two different radios in two different locations. But it was a simple matter of digging a short trench, cutting the coax, running it into the barn, and putting a new HF radio in. Now, as I said, the problem was I wanted to use one antenna in two locations. Simple solution, alpha delta coax switch. 75 bucks at any of the ham radio dealers. Flip a switch to put it in the house, go back to the other position to put it in the barn. It was simple, easy, and about 75 bucks worth of effort. The problem was, if you're in the basement, you have no idea, unless Supergirl happens to stop by, what position the switch is in. In addition, the remote tuner out at the vertical, if you want to force a complete retune and not use memory, you have to remove power, key the radio, and reapply 12 volts, and it forces a manual tune. So my arms weren't quite long enough to reach the injector out in the barn and do that with the ASU in the basement. So this is just a little block diagram of the simple solution. Coax from the antenna to the tuner to an injector with a 12 volt power supply, coax switch to radios, two locations. Works fine, lasts a long time. Well, then we decided to get new flooring. What's that got to do with ham radio? Well, I got evicted from the bedroom upstairs. Oh, I already talked about the retune. What I did for a retune while I was still in the house, I put in an Alexa smart plug and said, Alexa, turn injector off. Okay. Alexa, turn injector back on, please. So it was pretty simple. Then I got moved, when we got new flooring, I got moved into the basement so that the ham shack could be a guest room. Ooh, looks like my antenna fell down. Must be windy today. So the project was to replace the manual RF switch and the smart switch that was turning the injector off with something I could control via Wi-Fi, replacing these tunes. What I wanted this project to do is I wanted to control it from any web browser, my phone, computer in the basement, computer in the shack, as long as it was just internal to my own network. I didn't want any internet control from somewhere else. I wanted the switch to be mutually exclusive, so I couldn't hook up two radios to one antenna at the same time. I think that might result in some extensive repair requirements. I wanted everything grounded when it was off or not in use or disconnected. I needed the web page to display, is it on or is it off? And I want to remotely turn off power to the injector so I could force a retune. Pardon me. So what do I need to do this? Well, I've got to come up with a remote switch. I need a microprocessor, Wi-Fi, relay modules, power supply, and some software. You guys are over here on the left screen. That's why I'm turning my head sideways all the time. To look at you guys. So here's a remote switch. Simple, stupid. eBay. You can't, I mean, it was 27 euros from Czech Republic. So, depending upon the exchange rate, somewhere between around $35, $37. Now, if you're cheap and have a bucket full of stuff in your house, I mean, The only thing here is 2 relays, 2 varactors, 2 diodes, and some connectors, and the board. So if you got some stuff in your junk box, you can buy the board for 10 bucks. Populate it yourself. I played around with Mauser. I didn't have the relays. I had some of the other stuff, and I simply said, I'm going to buy the whole kit. And that's what it looks like when it showed up. So, in addition to the 2 solid components, there was 2 screw connectors that go to the board. Pardon me, screw terminals. You could simply just solder the wires to the board or put those in or whatever. You also need something to put it in, an enclosure. The guy that sold the board recommended a Hammond 1590B. I bought one. I think I got it from Amazon. Sold them up at High Plains because I didn't like them. They were too small. The original design, you had to take a little coping saw and cut the corners off the circuit board to make it fit in the box. Well, I wanted something a little larger and some mounting flanges on it. So I found this model number, and they're all available from Mauser. 8 to 12, 13 bucks, and then of course USPS, and you've got to have some money too. So here's the whole thing. This is pretty simple, straightforward. Punch some holes in the box. It did not come with the UHF panel mounts, but I had those in my junk box, and they're about 2 bucks a piece. I don't know, you get 5 of them for 10 bucks on eBay. Punch the holes, mounted them in, dry fitted, make sure it works. Then I put a star washer between the board and the SO239s so it would get a better contact on the ground plane, on the grounding strip on the back of the board. Used some nylock nuts so I didn't have to fool around with lock washers on this side. Some number 14 copper for jumpers. Arnie, what'd you say at breakfast that one morning? I said about my loops. So it's all done. Pretty simple, stupid. 2 12-volt relays, selects from common to 1, common to 2, whatever. So I got an RF switch, 35 bucks. Well, a little more than that by the time you get the box, the box and the connectors. So now it's time to get the control stuff. Here's where the Arduino stuff comes in. My first attempt was Arduino runs on 5.5, or 5 volts, excuse me. So I need a voltage regulator. The Arduino itself, a Wi-Fi module, a couple of relays, because this is 5 volts, so I got to switch 12 volts to this box. It worked. It was ugly. There was wires everywhere. The Wi-Fi module was finicky, difficult to work with. So my second try replaced the Arduino and the Wi-Fi module with an ESP32, which is basically an Arduino with Wi-Fi built in. And that got a little cleaner, and it worked. And I thought, now I'm looking for boxes to put all this stuff in, keeping in mind that this is a Wi-Fi module, so you can't put it into a metal box. It seems to reduce the effectiveness of connecting to your internet or to your router. So the last and third time's the charm, I got a module called an ESP12 with relays. One module, everything, all together. This is the ESP12, which, if you read this little description, is basically Wi-Fi and an Arduino platform in one chip. Pardon me. So, now, where'd I get that? Look at this cost of this thing. You're going to have to take out a loan to buy one of these. $8.88 on Fleabay, plus $3.50. This one's from Mr. China. You can also get them on Amazon, on eBay, and AliExpress, Banggood, all of those suppliers. So, and they run anywhere from, by the time you get shipping, 10 to 15 bucks for the entire module. And what's neat about this module, not only does it have the 4 relays, the Wi-Fi and the Arduino, It also has a built-in power supply. Let's see if I can make this bigger. How do I make this bigger? Let's try this. Did that work for you guys? Did it get bigger? Okay. This thing will run from 90 volts to 250 volts AC, right here, line and neutral, or it says here somewhere 30 to 5 volts DC. I want a 12 volt power supply. I got 12 volt relays. Cool. So all I have to do is apply 12 volts ground to this board. It's about 4 inches square, roughly. Let me get it back down to a paper size. It programs with the Arduino IDE, Integrated Development Environment. That's just their fancy word for their programmer. Programs through the I/O port here. You have to install the pins. That's the only soldering there was to this. The rest of these are screw terminals. Your relay common, normally open, normally closed. So whatever application, you've got both flavors. So, thanks to N7JJY, I got an old Motorola speaker, threw the speaker away, and that board almost matched up to the speaker mounting holes. But when I did that, the case had a big gap around it and whatnot, so I just cocked it a little bit, put in some 440 screws and mounted it. My 12 volts comes in on this pair, and the 12 volts jumpers underneath the board to the armature of all 4 relays to common contact. The white and the green wire go on out to the relay switch to trip those relays. So it provides isolation between the RF and the board. Cool beans. And like I said, you got to use a non-metallic housing because you've got a Wi-Fi module in. So here's the whole project all done. This is the injector that came with my tuner. It has a 12 volt coaxial type DC connector, RF in, and then the antenna. And what this does is it runs 12 volts down the coax, out to the tuner at the base of the antenna. There's a similar module on the circuit board in there which strips the 12 volts off before it goes to the tuner. And I have remote tuning. The Wi-Fi relay board is in the Motorola speaker. And then here's that RF switch box. I got a little piece of tubing and mounted it sideways. And all this is down underneath by the side of my desk. And it works rather nicely. 66 bucks, roughly. Versus, I had to buy a cable. I have a module that you can solder to the board and then use a USB connector. But cable that pushes on the pins was easier. I could use it on any board. It was a whopping $4. I didn't even need permission from my wife. Comparable cost, but a whole lot simpler. That's the end of the description. Anybody got any questions? And then I'll move on to playing with the Arduino and show you the board and so on. Nut and honey. Not that up there yet. This is the instructions that I found on the internet for the module. That 4 relay ESP32, ESP12, okay, 90 to 250, 7 to 30 volts, blah, blah, blah. In fact, that's where I got those pictures we were just looking at. It very nicely outlines all of the GPIO pins, what they're for, how it's set up, how to program it. Use a jumper to connect IO0 and ground. And here's the TTL serial plug. The
Greg, you still got the switch box up there.
I got what box?
Switch box.
Yeah, it's a picture of the original switch box.
What do you see now?
Nothing changed.
Okay, well, I'll fix that shit. New
Yeah, we're
shit.
seeing the Word document.
How about now? You got a PDF? LC Relay ESP12?
Yeah.
Okay. So that's what I was reading from. There's the 90 to 250 and so on. The pictures of the boards, as one we just saw previously. And the fact that this chart outlines all the general purpose input output pins. What's important is 5, or not 5, yeah, 4, 0, where am I on? This doesn't match my board. Must be a different one. Joe Heshikawa must have made one, and his brother Bob made the other one. But they use different pins. I'm using 12, 13, 14, and 16 on my board. I guess I didn't catch that before. Here's the programming information on if you wanted to make your own cable, development board, and a TTL serial module. For $4, you can't go wrong, you know. Now, if I close this, screen sharing has stopped. Okay, that's fine. Share screen, and I want to share this. Are you seeing an Arduino and my desktop?
Yep.
Okay, now I want to open. You seeing more than one window? Have you seen the board over here?
Nope.
Well, maybe I got to get everything and then share it, huh? I practiced this, but not with somebody connected.
It's always harder when there's an audience. Something always goes wrong. You can't help it, you know. It's Murphy.
Okay, now do you see multiple windows?
Yes.
Okay. So, got to get one more. This is the board. Hopefully it'll get a little bigger. And what's neat about this, I found out that these $19.95 and $29.95 webcams, they ain't worth a poop for close-up. But did you know that Harbor Freight is into computer supplies, and they have an 80-column adapter for $2, which slides in here like this. Look how that cleared it up. And it was $2 instead of $55 for a new camera.
Was that a clarifier? Do they actually call it that?
I think if you get the clarifier one, it has a tinted lens and it's like rose-colored glasses. At any rate, that's the board. 4 relays, the 4 connections. This is my cable that I bought that's currently connected 5 volts, TX, RX, and ground, and it goes over to a USB port on my computer. And once we get the computer disconnected, I'm going to run it on a 9-volt battery just so you can say, hey, there's no electrical connection between the computer. It really is Wi-Fi. The programming is anybody here got experience with C++? Okay, okay. It's not hard. Nothing's easy, but it's always hard. Yeah. Look where I stole it from. Initial code from Rui Santos at randomnerdtutorials.com. You can find anything on the internet. Okay? So I went to this website on Random Nerd Tutorials, and here's how to control a relay with an Arduino from a web page. So then I added, subtracted, that didn't work, and version 4 was the final. In fact, I don't want to open this one because this is my real one. Let me open the demo one, so if I hose something up, did that pop on the screen? You still see it? Okay. So this is the demo one. That way we can screw it all to heck. Doesn't care. So in this environment, a double slash is a comment. It's not a piece of code. You can write Bob's your uncle or whatever. A single slash and an asterisk means everything that follows till you see another asterisk is a comment. So all these are is just comments and notes and blah, 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 blah. Now we get into the meat and potatoes and load a Wi-Fi library. Okay. These are my network credentials, so it'll log on and find my router. There's some stuff I don't know about this. It just works. We got to have a Wi-Fi server. I'm not too good on it. And here's the relays. And I'm using general purpose input-output pins 12, 13, 14, and 16. Why didn't I put them in order? Why is it such a goofy order? Well, relay 1 has 16 next to it. Relay 2 is IO 14. So on and so on. So that way I just use little Berg jumpers to connect IO 13 to relay 4. So on and so on without having to use wires and all that sort of stuff. So my sketch, as they call it, followed the printout on the board. I set the output as a default to store the current state. They're all on, it says. All off is the label. So this is just variables. So if I want to use a different GPIO on a different board, all I got to do is change 16 to 29. And the program works on a different pin. So you don't have to change the everywhere in the software to 29. Now, serial begin, this turns on a serial port monitor so you can monitor what the thing's doing in communication back and forth. The setup, these are constants, time constants. An integer, a string, on, string off. We have to tell the device what pin 16 is. It's an output. It's going to put out power. If we set it to an input, that would be somebody opened the repeater door and it sent 12 volts to the product. So that would be an input. It's reading something from a different source. But all these are outputs because we're going to turn relays on. Then I make sure they're all turned off. Low puts out a ground or removes 5 volts, however you want to say it. It's the same darn thing. So, and it takes a high, which is 5 volts, to energize the relay. So this setup runs only one time. So we set the outputs, turn all the relays off in case there was a power bump or for whatever reason. It turns everything off and the antennas are grounded. The antenna's grounded and the radio's grounded. So, are we still in this setup? Okay. It connects one time. It connects to the web server and an IP address if the serial monitor is open for us to see it. Now we go to the loop. Setup's all done. It's never going to use it again unless it loses power. Loop goes over and over and over. That's the meaning of the program. It goes up the top. Did anybody send me anything? Nope. Did anybody send me anything? Oh, somebody turned on relay 4. And it'll do something. So that's what the loop is. And unfortunately, I got to get with Debbie or somebody that knows C++ or answer some questions for me on how some of these things work with the web page. I'm not all that educated. But like I said, I got it from somebody else and tailored it to my needs, and it works. And I still want to find out about it. Let me get this a little bigger. I'm going to click on this while we're doing that. So GPIO 416 is relay 1, I think. Yeah. So it goes out and checks, and if somebody says, oh, it gets a command to turn on, it executes these things, turns that off, changes this label, and then updates the web page. And all of these are all looking for the 4 relays. I'm getting, okay, this one got messed up. This one should be So this is a comment now. None of this code will ever be seen or ever be executed. There's 4 relays on the board and I only needed 3. So that's why this one's marked out. For the demo, what we're doing here, I turned it back on so we could see it operate. So spare relay number 4, GPIO 13. Now we get into some web page stuff. This is where you can tinker and screw stuff up and make stuff pretty and make stuff ugly. Feel free to change background colors, font sizes, blah, blah, blah. I chose green. Green is out, blue is in. See how this one's remarked out? If I change that and remark this one, it changes it from blue to green or whatever, okay? What it prints on the label, workshop, plus label 16 state, which was way up in the top. We said label 16 state was off. Label 16 state is on. So it'll print workshop, online or offline or whatever you set for a variable. The button itself changes to shop from off. So you could tinker with these, and I ended up with version 2.1, 2.3, 2.4, 2.5. Oh crap, that didn't work. Go back to 2.3. So every time you make a change and it's finally right, save it as a new version. That's the way it worked for Greg. And that's pretty much it. It's the end. So what I did before was I clicked the verify button so it would compile and make sure there weren't any errors. And it did. Now I'm going to go to the other camera. You won't actually see anything happen. Oop, don't want that. We still good? You got 2 windows? Where's my jumper? I hate when that happens. There you go, cleaning up.
It's only 50% complete.
Yeah, something like that. Ah, here's one. A green one. So in the instructions earlier, it said to program it, I had to short GPIO 0 to ground. Yep. So I got a jumper from GPIO 0 to ground. I'm going to reset the board. There's a little reset switch right here. If I can. And hopefully it'll program. Like I say, you see no activity on the board. Nothing's happening with an Arduino or the 8266 or some of the genuine boards. There's an LED that flashes with this transmit and receive serial upload. This says it's compiling the sketch. It's almost done. See, compiling over here. Now it's connecting to COM port 7. I hope it found it. 7% complete, so on and so on. So it's uploading the code to the board. See, the board's not doing nothing. We got a little flash on the Wi-Fi module because it's not connected to the, it's not connected to the router. So it uploaded successfully and reset the board. I got to pull off my jumper or it won't run. Let's see if I can make this a little smaller. Oh, serial port's right here. I lost it. I'm going to reset the board. It's connecting to my Wi-Fi and gave me an IP address of 167. Now, what I did for this is a demo board. What I did for the one that's in there, I went to my router and, oh, there's 167. There's the MAC address. and I told the router that if you ever see this MAC address, always assign IP43 so that I can find it from any computer, and you might turn it on tomorrow, and if it's, what's the IP? Because you only get this when your serial cable's connected to the computer. So we know it's 167. I'm going to try and open another window and see if it shows up on the. Did that did the antenna switch show up? It did. Okay.
Yeah.
See Shy Club. Okay. So I'm going to type that IP address
Yeah.
we had, 10.0.74. What the heck was it? 167. Yep. So there's the remote switch. That's what the web page would look like. I got it scrunched down so we can keep everything on the screen. I'm going to drag this over here, drag that over there, and I'm going to turn this light off. Right? Can you see my mouse? There's 4 LEDs on this board. Correspond to relay 1, 2, 3, and 4. So if you see it says workshop off, basement off, injector off. If I click injector, or any label that you mess with in that code, whatever you want to call it, window open. Injector is on, changed to blue, and LED came on. Turn the injector off. And the serial port, you can see the communication between the board and the computer. Disconnect that. In fact, we're going to do that. I'm going to disconnect the computer. All the LEDs went off. And this genuine, more Harbor Freight.
So you said you had that connected up via USB to your computer, right?
Right, the programming cable.
Okay.
So now it's just running on a 9-volt battery. It's no longer connected to my computer. See, these pins are all clear. I pulled that cable off. So all this is running on is that 9-volt battery. If I turn the workshop on, and if you'll notice, it's hard to see, it toggled. I can either have the shack or the shop. It won't let me connect 2 radios to that one antenna port. So if I'm down in the basement in the shack and I need to retune, I turn the injector off, key the radio, turn it back on, and that remote tuner retunes. This is the demo. Now, address 43 is actually my vertical antenna, the one that I have in service.
So you need that injector to run that remote switch, is what you're saying.
The injector runs the remote tuner.
I mean the remote tuner, right?
Right. So if I turn the injector off, the tuner's bypassed, and I could use the tuner in the radio or something else. It's just a 43-foot stick.
Okay. Gotcha.
So, let's see if we can. Wow, 20 meters went in the crapper. Imagine that. He stopped. Disconnected the antenna and went quiet. Somebody's 5'9". That's pretty much it. I find it's great. I can go down in the basement in the morning with my coffee. I wonder where I left the antenna. Doesn't matter. I just open up this web address, 10.0.74.43. Actually, I think the one downstairs, I made a shortcut on the favorites bar, and I just click on it. It says antenna. Opens up the web page. Now, I still have that Alexa switch in there to turn power off. I guess I just got to crawl under the desk and pull it out. Alexa, turn injector off. Okay, she turned it off. So I'm going to close this and open up a new web page. 10.0.74.43. And this should end up with a 404 timeout because it doesn't exist. I turned power off.
Right. So Alexa, when you say turn on remote injector, how did you? That kind of I don't understand that.
Okay, that's just a $12.95 smart switch on Amazon. I think it's made by TP-Link. You plug it in, give it your router information. She connects to it, and you can control it. You can set it. I got one in the basement that turns lights on. I got another one on a recirculation
I got
for
you.
my water.
I got you. Yeah. Okay.
Linda's got a smart bulb in the bedroom.
smart switch.
Yep.
Yeah. Okay.
So, and it's just a little 3-amp power supply. I think the remote tuner only needs 1 amp. So the smallest power supply I had laying around was a little 3-amp. I don't even know. It's not, one of the ones we used to sell at ComSource, Pyramid.
Wall warts. Yeah.
Yeah. Well, no, it's an actual 12-volt supply, little
Power
box.
supply. Yeah.
So let me shut all this stuff off. Actually, I just stopped screen share, right? No, I don't want a new share. How do I stop screen share? You are sharing, stop share. Oh, you guys are back on the screen now. So what do you think? Comments, questions?
I think that's
Well
pretty cool.
done.
Yeah, I think that's pretty cool, man. I mean, because you got 2 operating locations, and you want to work off of both of them. But I'm in one place. I got that switch. Yeah. I go over here and I crank that, and then I go, oh, what antenna am I on? And I crank that, and I'm on. Whatever radio, whatever antenna. But that's cool. I like that.
The other thing I've got is when I was up in the bedroom in the house and I had nothing out here, all of my coax cables and rotor cables went to a big Hoffman box outside the house with all of the surge arresters on control lines for rotors. Everything's outside in the Hoffman box. Then the cables went in. So I've got another alpha delta switch that goes from 2-meter sideband, dual band vertical. That goes to my IC7000. I've got another coax switch in there that goes to my dual band FM everyday UHF, VHF, FM talkie radio that goes to an outside antenna or to a, what's arrow antennas? J-pole, up to a J-pole in the attic. So for severe storms, I can flip to the J-pole in the attic and disconnect the one outside. I've got one more switch that I don't even remember what the hell it does. Well,
So these are all these switches are still in your house.
right,
Down
and
where
they're
they
still
are.
alpha deltas.
Yeah.
So the next project, since I'm in the basement and they're upstairs in the old shack in the closet, because when I remodeled, I put the new shack underneath where the old one was, and all the cables went through the floor and connected, and I didn't have to do anything new. Simple, stupid. I've got an 8 relay module, and I only need 2 relays per switch. So I'll probably end up doing something for that. But it's been it's so hard for me, anyway, to learn what does this stuff do, how does it work, if you don't have an application. You could sit all day with Arduino and read a lesson online and hook up 2 LEDs and make them flash faster, make them flash the other direction, put a pot on it and dim an LED and all this stuff. Okay, so you learn a little bit about the code, but what am I going to do with it? Till you have an application, it's really it's not fun. So coming up with, oh wow, I got a use for this darn thing. And that's pretty cool. Because the only other project I ever did with Arduino was the Lusk repeater. I built a repeater controller for that old GE, and that was all stumble and error. But anywho, that's it for the RFs or remote switch of any kind. Another application I had, I fixed it cheaper. I've got a Ameritron RCS 456 or something, remote coax switch.
RCS4.
Yeah, I think it's got 4 or 5 outputs and
Right.
rotate. Well, the knob went out. I thought, well, I guess I could replace that with this gizmo. But MFJ, who bought Ameritron among other things that they bought, had the switch in stock for $4. So
I've got an RCS4 that's sitting over there on the bench that needs to be fixed. The relays went out. It took a little bit of a lightning hit. I think it got some some electricity down in them relays, and it just they would not they wouldn't work. So I took it off of the.
this same guy that I got got from eBay, the coax switch, they have a 6-in-1. They have one input and 6 outputs, so you could replace the whole board.
Yeah.
Is this 12 volts? And I know that Ameritron is as well.
Yep. So yeah, I'll look at that. That'd be easier than trying to find the relays and swap them out and all that.
I guess if we're just shooting the breeze, we could stop the recording unless anybody